Alright guys, so today we are going to be graphing parabolas when they're written in standard form. So remember, standard form is ax squared plus bx plus c. So this is a little bit different than vertex form. We do want to find the vertex and the axis of symmetry. Then we want to find two ordered pairs on our graph. And then we want to know if we're going up or down. Okay, so let's do an example. So number one, we don't have vertex form, so we need to figure out what our x value is, and then we're going to plug our x value in. So in order to figure out what x is, it's negative b over 2a. So we plug in what we have. Negative and negative, or b is negative 12, so it'll be negative 12 over 2 times a, which is 1. Negative 12 is really positive 12, and 12 divided by 2 is 6. So our x value is 6. So now we're going to plug our x value in to figure out what our y value is. So we have y equals 6 squared minus 12 times 6 plus 40. So I'm just going to type all that junk in my calculator. Remember, when you take out an x and you replace it with a number, that you should put parentheses around it. That way you don't type it incorrectly. So we have 6 squared minus 12 times 6 plus 40, and that is 4. So our y value is 4. So that means the vertex of this parabola is at 6, 4. The axis of symmetry is wherever our x value is for our vertex, so x is 6. And then since my a is positive, this guy opens up, which is important for what we're going to talk about next. Okay, so we're going to graph the vertex. It's at 6, 4. And this picture is going to go up, so it's going to go like this, but we're going to figure out some ordered pairs, two ordered pairs for this guy. So the vertex is at like the bottom or the top of the parabola, which is like a U shape. And it's at the bottom this time because we know that our parabola goes up since our a is positive. So we want to try to figure out what our intercepts are with our x-axis, but this parabola is never going to touch our x-axis. So my suggestion to you is to pick one number, one x value, to the left or to the right of your vertex to plug in and figure out what your next ordered pair is. So let's just pick 7. And the reason that I say 1 is because parabolas grow really fast. So if you pick something that's further away, you're most likely not going to have that ordered pair on the graph, which would make it hard to see what's happening. So we'll just pick 5 for our x value. We're going to figure out what our y value is when our x value is 5. So again, when I take out my x, I'm going to replace it with my 5, and I'm going to put it in parentheses so that I don't accidentally mess up. So basically, instead of 6 here, I've got 5. And I'm typing in everything as I see it. And I got 5. So we have an ordered pair of 5, 5. So I have a dot that goes on 5, 5. So this half of my parabola looks like this. Now, remember, your axis of symmetry cuts straight through your vertex, which is our equation x equals 6. And it's basically, if I were to fold this vertex in half, all the things on the right would match up with all of the things on the left. It's like a mirror line, like a reflection. So since from the vertex, this ordered pair is over 1 and up 1, then on the opposite side, it's going to be over 1 and up 1. So we also know by figuring out what one of the ordered pairs were on one of the sides of the axis of symmetry, we also know the other one too. So it will be 5. No, wait. Oh. Shoot, I graphed 7, 5 when I meant to graph 5, 5. Okay, well, it's the same idea. And then here's the other side. That's what it looks like. Okay, sorry. Let's try not to mess up on the next one. It's okay, I fixed my mistake. It wasn't really a mistake at all either. Okay, so on this guy, we again want to do negative b over 2a. So that's negative 12 over 2 times negative 1. So that's positive 12 divided by negative 2. That's negative 6 for our x value. Then we're going to take that x value and plug it into our x's. So we have y equals negative 6 squared minus 12 times negative 6 minus 39. So make sure that you put this guy into parentheses so we don't accidentally make mistakes. Okay, so it's negative 6 squared minus 12 times negative 6 minus 39. And we get negative 3. So when our x value is negative 6, our y value is negative 3, and this is our vertex. Since our a is negative, this actually opens down. And our axis of symmetry is always whatever our x value is for our vertex, which is negative 6. So we're going to go over to our grid, and we're going to graph negative 6, negative 3. And this guy does not go through the x-axis either. I'm going to show you examples of ones that do. Okay, so for this guy, I'm just going to pick one number smaller than 6, than negative 6, and plug that in and see what my y value is. So y equals negative 5 squared minus 12 times negative 5 minus 39. So it's the same idea, but instead of a 6, we have a 5. Like that. And our answer is negative 4. So when our y value, when our x value is negative 5, our y value is negative 4. So we're going to put a dot at negative 5, negative 4. And again, with this axis of symmetry, it's down and to the right. Well, it's going to be down and to the left on this side for our parabola as well, because I should be able to fold our parabola at the axis of symmetry and have all of my ordered pairs match up. Okay, so let me show you how to figure out the x-intercepts. Let's look at number 10. Okay, number 10. All right, so negative b over 2a, negative 2 over 2 times 1, which is negative 2 over 2, which is negative 1. So our x value is negative 1, and then we plug our x value in to figure out what our y is, so be careful. It's negative 1 squared plus 2 times negative 1. So remember, any number squared is going to be positive. So 1 minus 2 is negative 1. So our vertex is at negative 1, negative 1. Our axis of symmetry is x equals negative 1. And because my a value is positive, this goes up. So we have a dot at negative 1, negative 1. That's our vertex. Okay, now I know that this parabola is going to go up, so it's going to cut through my x-axis. If it does, you should practice figuring out where your intercepts are. So how you do that is we got to get the y equal to 0. So because if we have dots on our x-axis, we're not moving up or down any. So if your parabola goes through your x-axis, then you're going to solve for x. So you set y equal to 0, and now we have x squared plus 2x. Okay, so you have two options here. You can big X factor, and you can multiply to get to 0 and add to get to 2. So what numbers multiply to 0 but add to 2? 2 and 0. Or you could do it a different way. You could GCF factor. So I have an x squared and an x, so that means I have an x in common. So what I have left over is 1x plus 2. Which really means that this guy is got nothing added to it, right? X plus 0 times x plus 2, which is exactly what we got when we big X factored. Okay, so now this is how you solve for x. You take each of these factors and you set them equal to 0. So I have x plus 0 equals 0 and x plus 2 equals 0. And we've practiced this before, earlier this year. Okay, minus 0, x equals 0. Minus 2, x equals negative 2. So then I put dots where my x is 0 and my x is negative 2 on my x-axis. Okay, so I have a dot at 0 and I have a dot at negative 2, which helps us draw our parabola. Okay, so we're going to do that one more time so you can see it. I think we can do it on... Oh, I can't remember. Okay, hold on, let me look. Okay, so we're going to try number 5, and I'm going to show you what this guy looks like. Okay, so we start off this guy the exact same way, negative b over 2a to get our x value. So negative b is negative 16 over 2 times 2, which is 4. Negative 16 divided by 4 is negative 4. So that's our x value. And then for our y value, we're going to take our negative 4 and plug it in. So we have 2 times negative 4 squared plus 16 times negative 4 plus 29. Type all this business into our calculator. Okay, 2 negative 4 squared plus 16 times negative 4 plus 29, and we get negative 3. So y equals negative 3. So your vertex is at negative 4, negative 3. Since this is positive, it's going to open up. And my axis of symmetry is at x equals negative 4. Okay, so negative 4, negative 1, 2, 3. And it opens up so I know it crosses my x-axis. So since I know it crosses my x-axis, I'm going to set my y equal to 0. Okay, so I have 0 equals 2x squared plus 16x plus 29. So in order to solve this one the easiest, we are going to big X. So remember, when you have a leading coefficient, you have to multiply your leading coefficient and your c, your a and your c together. So we have 29 times 2, which is 58. So we're multiplying to 58, and then we're going to add to 16. Okay, multiplying to 58 and adding to 16. Oh no. 8. Okay, so adding to 16. What's 8 and 7? No, 50. Oops. Okay, 50. Ah! Divided by... Did I do that one? Oh. Ugh! 2 and 29. Okay, hold on. Let me make sure I'm doing this right. Okay, so here's my problem. I didn't realize until I started trying numbers, but this parabola doesn't actually cross at the corner of boxes, so to factor this to big X factor is not going to be nice, okay? So, because like 19 times 3 is really close, but it's not quite there. Okay, so when that happens, because 19, 18, 17, 16, 19 minus 3 will give me 16, but it doesn't quite make 58. So that it just means, because I can't figure out nice, pretty numbers, that it's not going to cross the x-axis at an ordered pair. Okay, so instead, it'd be easier for this guy just to do what we did for the other ones and just pick a number and plug it in. So I would pick like negative 3 and then plug it in and see what our ordered pair is for negative 3, because we can't get on the axis. So anyways, let me know if you have any questions. Okay, bye.